All right, let's go ahead and talk about worksheet 40. So, a lot of these problems, I know there's a lot going on. If we just follow our solving order from yesterday, here, let me pull that out. Chapter 7 notes, 7.4b. So, our solving order from yesterday, if you remember, yesterday being Wednesday, we're going to distribute first, always distribute first. Then we're going to bust any fractions if possible, combine like terms on the same side. We're doing all these things before we start doing our inverse operations. Once we start our inverse operations, we're going to focus on the variable terms first, getting those all to one side. And then we're going to get our constant terms over to the other side. All right? Then we'll have a variable term on one side, a constant term on the other side. We'll divide both sides by whatever number's in front of our variable and state how many solutions we have. So we're going to start with distributing. In number 1, we distribute the 6 to the 2 and to the 4x, but this x out in front is untouched for the time being. We're not going to do anything with that x. We're just going to multiply 6 times 2 and 6 times 4x. The right side of our equation stays the same as well. 6 times 2 is 12. 6 times 4x is going to be 24x. Again, that x is still out in front. I'm going to go ahead and split my equation now. And this x, even though it's all alone, we're going to put a 1 in front of it, right? Because whenever we see x all by itself, really it has a coefficient of 1. We just don't technically need to write that 1, all right? But we are going to, because now we're going to combine like terms. Right? First we distribute. There's no fractions here. So let's combine the 1 and the 24x just like that. So we get 1 plus 24x plus 12 equals that right-hand side. So now we have 25x plus 12 equals 12 minus 3x. Now this is the form that we want. We want to have a variable and a constant on one side and a variable and a constant on the other side. That tells us right away it's time to do inverse operations. So we'll bring our variable term over to the left by adding 3x to both sides. They cancel out on the right, just leaving 12. And 25x plus 3x gives us 28x, still adding 12. We brought our variable term to the left. Let's bring our constant term over to the right by once again subtracting from both sides. Let me extend this line down. 12 minus 12 cancels out, and over here on the right, 12 minus 12 also cancels out, but we can't have nothing on the right-hand side, so we're just going to write 0. Because 12 minus 12 equals 0. We bring the 28x down, and our last step is to divide both sides by the number in front of x, which in this case is 28. 28 over 28 cancels to 1, leaving us here with x equals 0 over 28. Well, 0 over anything, 0 over 1, 0 over 1 million, is equal to 0 no matter what. So because we have x equals 0, this is going to be one solution. You may think, oh, if x is 0, then x is nothing, so therefore it's no solution. That's not the case. Remember, this is what we're looking for. One solution is letter equals number, even if that number is 0. It's only going to be no solution, when we have different numbers on either side of the equal sign. That's going to give us no solution, and we'll see that eventually. Let's take a look down at number 3. So number 3 is a little bit tricky because we have a negative sign in front of this, this grouping here. And really what that is a negative 1 out in front. So we're distributing negative 1 to the x and to the negative 5. Left side stays the same. Now we have negative 1 times x minus, right, we just bring that sign down, negative 1 times 5. Okay, we'll add these up, or I'm sorry, we'll multiply these up and get negative 1x. I'm going to put a 1 here in front of this x as well. Two minus signs right next to each other form a plus sign, and 1 times 5 gives us 5. Really take some time to see what I did so far, because these double negative signs get really, really confusing. So if you need to pause, maybe rewind a little bit and listen to that again, definitely do so. All right, now we're going to do our inverse operations because we have variable term on either side and a constant term on either side. So let's rearrange this equation so that all our variables are on the left and our constants are on the right. We'll add 1x to both sides, giving us 2x plus negative 1 equals 5. And then we're going to add 1 to both sides as well. 1 minus 1 cancels. 5 plus 1 gives us 6, and we still have that 2x on the left. Now our final step is going to be to divide both sides by 2. 2 over 2 is just 1, so x is going to be equal to 3. Because 6 divided by 2 gives us 3. And this is once again going to be one solution. Let's go down to number 6 now. I'm just going to jump around here and do different problems from each little section. So again, we have this negative 1 out in front. I'm going to rewrite that as a negative 1 in front of my parentheses just so I don't forget. And then I'm going to distribute that negative 1 again to both terms in the parentheses. Equals, we got negative 1 times 3x, bring that plus sign down, negative 1 times 4. It's really important that you keep this sign in between, okay, because you don't want any sign confusion here. That's where you're going to make a mistake most likely, if you're not careful. Negative 1 times 3x is just negative 3x. A plus next to a minus sign is going to give us a minus sign, and 1 times 4 gives us 4. All right. Again, variable term, constant term. Let's rearrange this by adding our variable term to both sides. We see that minus 3x plus 3x cancels out. And then we see on the left-hand side something peculiar, because this is the same thing. Negative 3x plus 3x, those are going to cancel out, leaving us with negative 9 equals negative 4. Now ask yourself, does negative 9 equal negative 4? No, it does not. This is a false statement. Therefore, we have no solution. And what that means is that no number, no input, is going to give us an output that we want for this function. Basically means that this function is broken in a way, is one way you can think about it, right? If a function is a machine, we talked about an oven, right? Inputs being brownie batter, output being brownies. This is an oven that doesn't really work too well. Okay, maybe it's an oven that is supposed to be at 400 degrees, but there's some faulty wires and it's kicked up to 500 or something. I don't know. Basically, you want to think about equations as machines, all right, with inputs and outputs. And this type of machine is not going to give us an output we want, like a jammed copier. Let's flip over to the back and we'll do a couple over there. Let's do number 7, and then we'll do number 12 and 11. 11, 12, 7, then we'll be good to go. All right. Once again, we're going to distribute first. 3v minus 5 times 4v minus 5 times 2 equals the right-hand side. Notice how I kept my minus signs exactly where they're supposed to be. And all I distributed was the 5. Not the minus 5, just the 5. 5 times 4v gives us 20v, and 5 times 2 gives us 10. But we still have that 3v minus out in front that we can't forget about, of course. And we have way too many terms here. Well, we have one too many terms here on the left-hand side, so let's go ahead and combine these like terms. We see that they have the same letter variable, okay? So we can just add up the coefficients. We get 3 minus 20 v minus 10 equals, once again, that right-hand side. We haven't touched the right yet. Should all look the same. 3 minus 20 now gives us negative 17v minus 10 equals 23 minus 4v. We've got two terms on each side, which is what we like. One variable, one constant. So let's bring our variable term over to the left by adding 4v to both sides. Negative 17 plus 4 gives us negative 13v. And then we're going to bring our constant term over to the right by adding 10. The 10s cancel out on the left. And I feel like I did something wrong. What did I do wrong? Oh, I see what I did wrong. Okay. I'm going to leave this part in the video because this is an important error that you have to look out for as well. I messed up. That's my bad. This negative sign out in front, right? We actually want to keep it attached to the 5. Okay? So negative 5 times 4v minus negative 5 times 2. So really, I apologize for this, folks, if you're watching this.